With a system like this, let's review this a little bit, just to get some momentum. A system of equations involves how many equations? 2 or more. You could have 3 or 4 or 10 equations, but we're going to limit ourselves to 2. So a system of equations could have 2 equations. That's what we're going to have here. It's going to have 2 unknowns. It's going to have an x and a y and 2 equations. On a graph, what is the solution represented by? The intersection. That's right. So wherever the lines cross, that is going to be the solution. And so we've basically only talked about that, right? We graph the lines, we see where they cross, and that's the solution. Like I said, the calculator will help you immensely with this. In order to use the calculator, both of those lines need to be in slope-intercept form, and right now, not, right? They're not. And so we need to put them in that real quick. And the first one is going to be super straightforward. It's going to be just subtracting the 2x over. Wouldn't it be y equals 12 minus 2x? The other one's a little tougher. I'll do this off to the side. I still would need to subtract the 2x, but what's hanging out there is we still have a negative. So if I go minus 2x, I would get negative y equals negative 2 minus 2x. Good morning. And then that negative on the y, it didn't go anywhere, right? It's still there. How do I get rid of that negative that's on the y? Yeah, divide by negative 1. Yep. So if I divide by negative 1, all that really does effectively is change all the signs. So that would give me y equals positive 2 plus 2x. So what I'm going to do, I'm going to write these down just so I don't forget them. I'm going to switch screens over to a calculator. We'll go to those calculator button pushes to make sure we know what we're doing with that. So here are the 2 lines in my system. And let me switch screens to a calculator. Here we go. So here's how we do this. So you turn a calculator on, you're just on a blank screen like this. What we want to do is we want to go to our y equals menu, like our equation input. So if you guys remember, that is the y equals button, the one that just turned red up there, upper left. So go to your y equals. If you go to y equals, you might have equations in there. You can see that I've got one in there. I'm going to go ahead and get rid of that one. The way that you get rid of it is just to highlight that particular expression and just hit clear. So just push the clear button and that goes away. So I'd want you guys to start off with just a blank screen like that. That work? Anybody not there right now? Okay, so what I'm going to do is I'm going to enter both of those lines in. So the first one is y equals 12 minus 2x. That's going to be my y1. So it'll be 12 minus. Have you guys picked up on the idea that there's a button for subtraction and there's also a button for the opposite of? I'm going to keep those 2 straight because your calculator won't like it if you mix those up. So 12 minus 2x. So there's the 2. And then you guys remember the x button is right there by the green button? It's that XT Greek letter N button. So if I push that, it gives me 12 minus 2x. So that's equation number 1. Equation number 2, I'm going to scroll down to y2. And I'm going to enter in the other one, 2 plus 2x. This is my second equation. So 2 plus 2x. So at this point, hopefully what you see on your calculator screen looks exactly like your system, right? It's like arranged vertically even. There's y1, there's y2. You got 2 different lines. There's your system. So, we good? So, Avery, your button pushes will be a little bit different, but in this case, yours are actually a little bit easier, I think. Yeah, it's actually pretty easy buttons on that one. Okay, so the next thing we want to do is graph this. And I'm going to graph it on a standard window. I don't know if the standard window is going to work for me or not. We'll see. But the standard window is this. If I push the zoom button and then 6. So zoom 6 will get me to a standard window. So once you enter those into the calculator, just go zoom 6. Hey, there's the blue line. And the red line is right there. Zoom. So zoom is up there right above delete. It's one of the skinny, like the little skinny buttons.
What were you supposed to graph?
You can, but your window can be moved all over the place. You can just put graph. I usually just push zoom 6. If I want a standard window that's like centered on the origin, I just go zoom 6. But if you've never moved your window around, you just hit graph and it'll do it.
Okay.
Just fine. Yeah. Anybody have any questions about what we've done so far? So when you look at your calculator screen, other than the color or non-color, does it look just like this?
Yeah.
Anybody say no, mine does not look like that? Ashlyn, what are you seeing? Oh, you know what? You've got plot 1 on for some reason. For some reason that happens with a lot of folks. And that messes things up. That should, yeah, looks like that'll work.
Maybe I can find.
Everybody else have a different screen besides that? You all have the lines graphed there? Are you on Desmos?
Yeah.
Yeah, Desmos is cool. Yes, sir. Of course you can. Okay, so remember that the solution to a system is where the two lines cross, right? And so you can see it. It's right there. My red line and my blue line are crossing. They're intersecting. And so your calculator will actually find that for you. It'll do all the work for you. Here's how you do it. Please pay careful attention to the buttons that I'm pushing. Don't be distracted. I'll go really, really slow. The first button we push is the blue button, the second button. So we're going to go second. And then over here, do you see the trace button? It's like one of those skinny buttons at the top. I mean, you can't see my mouse. So the trace button is about to turn red. Do you see the trace button? So you go second calculate, second trace, that gets us to calculate. And of the options up there, 1 through 7, which one do you think we would pick?
Value. Oh, intersect plot.
Intersect, right? Because isn't the solution to a system where the lines intersect? And so I'm going to find that intersection point. So I'm going to choose option number 5. Once you choose option number 5, you're going to get a couple of choices or a couple of prompts to respond to. So the first thing it asks you is, what is your first curve? And in just a second, it's going to ask you your second curve. Aren't there only 2 lines up there? So it doesn't really matter which one is the first or the second. And so what I'm going to do at this point, it says first curve, and one of them is the first curve, so I'm just going to hit enter. And then it's going to ask you which one you want to be the second curve. I'll just hit enter again, because there's only go. My screen kind of went to sleep there. We are recording this, and so if you want to go back later and watch, you can remember this. But yeah, go ahead. Okay, so I think, let's go back and look at the button pushes again. So let me quit out of this. So if I graph it, let's go over the button pushes one more time. I think you missed a step. So we're here. Are you on the graph now? So Connor, you too, get to the graph. And listen very carefully to the buttons. I think maybe you missed one step in there. Push the following buttons. Blue, or second, right? And then trace. So blue trace. Did you get to this screen?
Yeah.
You did? Okay, so then we chose option 5. So go ahead and choose option 5 again. So it wants to know first curve. One of them's our first curve, so just hit enter. You don't really need to make much of a choice there. So push enter. And then it says second curve, question mark. Push enter again. And then it says guess. So when it says guess, this is where you push the 2, because it looks like it's roughly 2, right? And then you hit enter again. And that's where it should give you your intersection point. Did you get an answer like this time?
I just figured out to press enter one more time.
Got it. What about you? It work? Okay. So those would be your button pushes. Anybody else with a question? Pretty straightforward, but if you do miss one button push, it makes all the difference, right? You're telling your calculator to do something else. So, okay, calculator people, are we good? You will listen, you're going to find this so helpful. Today, we're going to look a little bit about something called substitution. Later on, we'll look at elimination. You can always use this to check your answer. Think about that for a second. Like if the question on a quiz says, please use substitution to solve this system. Well, you got to use substitution, right? But then after 5 minutes of working on it, you get an answer. Couldn't you then turn to the calculator and be like, I want to check my answer real quick? Isn't that awesome? You could leave that knowing for sure, yeah, I messed that one up, or I got that one right. And I know for sure because my calculator confirmed it. It's a really awesome tool. And there are going to be cases where you can just graph it on the calculator, answer done. So it's a good thing to have. Okay, good deal. Grab your notes. We're going to spend a little bit of time on this new topic. So grab your notes. We're going to be looking at section 4.2. No, please. Want to give you some ideas about what substitution is. Listen carefully, please. Substitution is based on the idea of equality. Let me give you an example of this. If we were maybe playing basketball, and in basketball you've got 5 players on the court and they play, but it's pretty common to have a substitute, right? So let's say there's 6 at every table. So let's say this was a basketball team right here, like this table right here was a basketball team, and they're out there playing on the court. And let's say that Cooper is my sub. He's sitting on the bench with me, and these 5 are out there playing basketball and watching them play. And I see, Emily's out there. She's giving it a good effort, but I can see that Emily's getting kind of tired. She's starting to make some mistakes. It's obvious she needs a break, right? She's getting kind of tired. She needs some water, just a moment to collect herself. And so Cooper's sitting on the bench, and so the next dead ball, I'm like, all right, Cooper, I need you to go in the game for Emily. So he runs up to the little scorer's table and says, I'm going in. And the ref calls him in. Emily comes out and she sits down. Remember, this is a basketball game, right? Listen, there's a point to this. Cooper goes in the game for Emily. Now, Emily's been playing basketball to the best of her abilities, but she's tired, so it hasn't been great. I'm supposing that Cooper's going to go in there and do an equivalent job, right? But instead, Cooper goes in, and the person with the ball, he immediately checks him right into the stands. Like, he runs up and just nails him, right? And, the ball goes flying. The referee blows her whistle, tries to call a foul, but Cooper just grabs the ball, runs down and scores, right? He doesn't even dribble or anything. He just runs down and scores. He's like basically playing hockey, right?
Yeah.
Check someone with the ball, steal the ball. Doesn't really matter that they went flying into the stands. In fact, he's thinking that was actually a pretty good check, Yeah. And everybody's just kind of like, what are you doing? If Cooper goes into a basketball game and tries to play hockey, that's not really an equivalent substitution, right? The only way this is going to work is he goes into the game and does like an equivalent job to what Emily was doing, right? That's how substitution works. He wouldn't really be a substitute if he went in there and played hockey. He would just be a chaos causer or something, right? Think about food. Have you guys ever been to a restaurant where, you look at the menu, you decide you want something, and you look at the side, and for me, maybe the side is like sauerkraut, and I look at that and I'm like, I'm not a sauerkraut fan, so by you delivering me some sauerkraut, you're basically wasting food, because there is no chance I'm going to eat that stuff. So I might look at the server and say, hey, I'm getting such and such a meal, and I notice the side is sauerkraut, so could I substitute? Have you ever done this? Could I substitute something for the sauerkraut? And so the server says, yeah, sure, you can substitute something for the sauerkraut. And I'm like, awesome. Can I have 20 large pizzas in place of the sauerkraut? The server's going to be like, no. Why would the server think that would be ridiculous?
Because that's a course. It's a main meal.
That's like a totally different value, isn't it? It's a main meal. It's like 20 main meals, right? Yeah. And so for me to try to substitute 20 large pizzas in for sauerkraut, it's not really a good substitution, because the sauerkraut has a value of approximately 50 cents or whatever.
Sauerkraut.
What's that?
It's got to be a lot of sauerkraut.
It would have to be a lot, yes. But the 20 large pizzas have a much higher value. So to make a substitution like that doesn't make sense. But if I were to say, yeah, I'd like to substitute the sauerkraut out, and I'd like you to substitute some corn or some beans or something equivalent to it, that would actually make sense, wouldn't it? That would be an equivalent substitution. So math is precise like that, right? So for you to be able to substitute something, literally what you're doing is you are removing something from an equation. You are erasing it. You're taking it out, but then you're replacing it with something that's equivalent, something that's equal. So remember, in math, the equal sign is super duper important. Basically, the equal sign means that whatever is on the left side and whatever is on the right side, even though they may look different, they have the same value. That's a really important thing. So you think about the sauerkraut, right? The sauerkraut and the bowl of beans, they really don't look at all alike, do they? But they maybe would have the same value, right? We think about Cooper going into the basketball game, and this time actually playing basketball. Well, he does not look like Emily. Emily does not look like him. But if he goes in there and plays basketball, he's doing an equivalent job, isn't he? Yeah. Make sense? Okay, so let's bring it back around to what we've been doing. We've been solving systems by graphing. Let's remind ourselves one more time. When you solve a system by graphing, on the graph, what is the solution? Oh my goodness. You're either not paying attention now or you weren't paying attention then. I'm going to say it again. When you're solving a system by graphing, you graph the lines. What are you looking for a solution?
Intersection.
Intersection, it's where the lines cross. You guys were all zoned out on me. You were thinking about 20 large pizzas. I knew it. And so that's a fine way of doing things, but you're going to find pretty quickly that that is slow and fairly inconvenient. Okay? I'm going to show you two better ways. The first one is this idea of substitution. In order to substitute, we need to have one of the equations solved for one of the variables. So I thought I would do number one here with you. We'll explore through a couple of these, maybe just one or two of these, and we'll get to your quizzes, and we'll pick this up again later. So here we go. Supposed to solve by substitution. Please notice the top equation. I want you to do this with me, but please notice that the top equation up here is solved for y. You see that? Mm-hmm. So what that means is that the y on the left has the exact same value as the 5x minus 2 on the right. So what we're going to do is we're going to look at the other equation, and we are going to locate the y, and we're going to take the y out of the game. We're going to substitute the y out of our meal. And what is the only thing that I can put in place of the y?
9.
Nope. So what I'm going to do, let me explain this. I'm going to take this equation right here, the 6x plus y equals 9. I'm going to take that equation right there, and I am going to remove the y. The y is totally gone because they're getting tired in the basketball game, or it's the sauerkraut that I don't want, whatever, right? What is the only thing? There is only one thing that I can put in place of that y that's going to be okay, that's going to be mathematically correct. Will? Y. That's exactly what y equals. So because y has the same value as 5x minus 2, I can remove any y's that I see and replace that y with 5x minus 2. So notice how I've removed the y completely from consideration. I'll get rid of my line. That line's not that important. But I'm going to replace the y that used to be there with 5x minus 2. That is the only thing I can put in place of y, because that is what, as Will said so eloquently, that is what y is equal to. So I can make that substitution. It was truly eloquent. Well, I mean, what can we say, right? So I want to pause right here. Does that substitution concept make sense to you? Yeah. I can remove the y, but I can only replace it with the thing that the y is actually equal to. Once you get here, we're back to our pretty standard equation solving that we did in Chapter 2. Notice on the left side there's some simplification that could be done. 6x and the 5x are like terms. So what is 6x plus 5x? So we get 11x minus 2 equals 9. When I get the x by itself, I got to get rid of the 11 as well as the negative 2. Which one probably should be gotten rid of first? The minus 2. How do I get rid of minus 2? So we're going to add 2 to both sides. That leaves me with 11x equals 9 plus 2 is 11. And how do I get rid of the 11 finally? So when I do that, I end up with x equals 1. Now let's keep in mind, the reason we did all that graphing the last day or so, last couple of days, is because the solution to a system is the point of intersection. And x equals 1 is not a point. What do we need to go with that x? You need a y. You need the y. So if x equals 1, how do you think that I could find the y to go with that x? Does it matter which equation I use?
No.
Is one equation smarter than the other?
Yeah.
Which one would actually be a little wiser choice to use? What do you think, Victoria?
Y equals 5x.
Why is that the smarter one to use?
Because it's already in solution.
It's already solved for y, isn't it? Yeah, so let me do this really quick. It'll get your question. Don't forget your question, please. Okay, so I'm going to use, it doesn't matter which one I use, but this one will be easier. So I'm going to write y equals 5 times 1 minus 2. 5 minus 2, of course, is 3. So my solution is 1 comma 3. That is where those two lines cross. I think maybe you can already see this, but once you get good at this and get real efficient, this is actually way faster than graphing. Way faster. Okay, Ashlyn, your question.
So, if you get, like, equations and you have to solve for y, like, if it's, not solve for y, does it matter which one you use?
No, it doesn't. I mean, you could go
just
either
have to
way.
solve one.
Yeah, certainly. You could have, well, this one was set up pretty nicely for us, but we're going to find a couple coming up here that are not so nicely set up. We're going to have to do something like what you mentioned, and it doesn't matter. I think there are often going to be more or less wise ways of doing it, like ways that will make it easier or more difficult on you. but it doesn't matter. It doesn't matter at all. Okay. Anyone else with a question? Yeah. No. So you can certainly use that to check, but I will tell you this for sure, that on quizzes coming up, the assessments that you're talking about, there will absolutely be a question that says, please use substitution to solve this system. And so, a lot of the credit will be, in fact, all but one of the points would be tied to, did you use substitution? So, like, let's say, I'm going by memory, so I might be off on this, but let's say this was a 4-point question, let's just say. And let's say you just used the calculator and you got 1,3, you would get 1 of 4 points. Because you did get the right answer, so it's like, okay, sure, she knows how to get a right answer, but do you know how to do substitution? Maybe not. Make sense? But you could always use the calculator to check, right? And that's always a valid thing, I would say. Anybody else with a question? Okay, we got time for a couple more here. Let me help you real briefly with number 2, and then I'll leave the rest up to you. And Ashlyn, this will kind of get at your question somewhat, I think. Please notice in number 2, it says solve the system by substitution. But when you look carefully at the system, did you notice that on both equations, neither of them is solved for x or solved for y? Like, in other words, both equations, the x and the y, are not solved for at all. And so this is where we're going to need to do one additional step at the start. We need to solve one of the equations for one of the variables. And this is where, what I mentioned to you, Ashlyn, a second ago, is where you could make like a wise choice or an unwise choice. None of them are necessarily wrong choices, but wise or unwise. So as we look at those 2 equations up there, I see exactly one scenario that's going to be easier than all the other scenarios. So my question to you is, which variable do you think we should solve for? Well, x or y?
Y.
We should solve for y. And should we solve for y in the top equation or solve for y in the bottom equation? Okay, so let's talk about y, W-H-Y that is. Anybody want to explain like why we would go for Alec, specifically that one?
Because there's like no division, and the y's by itself already. So you just need to subtract it, 2x, and then you're done.
The thing you said at the start is pretty key. It's not going to involve any division, right? And if you're not going to be involving any division, that means there won't be any fractions. And we start throwing fractions into substitution, it's all doable, but it makes it a lot more difficult. So I agree with your assessment that it would be easier to take the bottom equation and solve it for y before we proceed. So that's what I'm going to do. To solve for y, I just need to subtract the 2x. So this would give me y equals 3 minus 2x. So I'm going to let you guys try the rest of this, see what you can do with it. I want you then to try to use substitution with that in the other equation and see how it goes. There's a few tricky steps in there, but I'm sure you can handle it. Give you a couple minutes to try. I know you're not done, but I want to make sure we have the substitution part squared away here. So what I'm going to do is I'm going to look at my top equation, and anytime I see a y, I'm going to remove the y in an effort to, substitute in. So I'm going to write it like this. I'm going to go 3x plus 4 blank equals -8. So notice the 4 remains, right? I'm simply going to be removing the y and replacing the y with what the y is equal to, right? An equivalent expression. So this is where you want to be super careful and probably use parentheses. I think that's really a must here. So I'm going to get rid of my little blank here, and I'm going to put parentheses. And what is the only thing that I can put in place of the y?
Negative 2x plus 3.
Yeah, exactly. So I'm going to put that right here. And at this point, I have definitely completed my substitution. I've removed the y, and I put the 3 minus 2x in its place. What property comes next? Distributive, yeah. So the 4 gets distributed across those parentheses, giving me 3x plus 12 minus 8x equals -8. I wanted to make sure we navigated that step correctly. I'm going to, again, give you just a moment here to try to finish that one and get to a solution. Put this up. Did you guys notice 3x and minus 8x are like terms? Definitely want to add those up before we do anything else. So this will give us -5x plus 12 equals -8. And then we want to get the x by itself. So do I get rid of the -5 or the plus 12 first? And how do we get rid of the plus 12? You're right. Thank you, Connor. So subtracting 12, we get negative 5x equals negative 20. Finally, we got to get rid of the negative 5. How do I get rid of this negative 5? Division, yes. Good. So divide by negative 5 on both sides. And, of course, the negative divided by a negative is positive. So we get x is equal to positive 4. Of course, that's only half the answer because it needs to be x comma y. So I need to take that 4 and I need to plug it back in. So which equation do you think would be the easiest plug back in? Yeah, and not just the bottom one, but maybe this version of the bottom one, right? Y equals 3 minus 2x, again, because it's already solved for y. So I would write y equals 3 minus 2 times 4. 2 times 4 is 8. And 3 minus 8 is negative 5. So my answer would be 4, comma, negative 5. That is where these two lines happen to intersect. Okay. Have any questions? Cool. Let's